Hello everyone, I Amit Dangayach. So today we'll be discuss about metal joining process. A metal joining process are manufacturing process in which metal pieces are joined by the application of heat by some means. The various metal joining process are welding, brazing and soldering. Welding involves heating the metals over a higher range of temperature up to fusion and then allowing it to cool. In case of brazing and soldering, the metals being joined are heated below their melting point. Joining includes welding, brazing, soldering and adhesive bondings of materials. They produce permanent joint between the two parts to be assembled. They cannot be separated easily by application of forces. They are mainly used to assemble many parts to make a system. Welding. Welding is a metal joining process in which the joining of metals is done by the application of heat with or without the application of pressure. Sometimes welding is done just by applying heat alone with no pressure applied. In some cases, both heat and pressure are applied, and in other cases, only pressure is applied without any external heat. Brazing and soldering. Melting of filler rod only. Brazing, higher temperature. Brass filler, strong. Soldering, lower temperature. Tin lead filler and weak. Welding, melting of filler rod and base metals. Two categories of welding process. Mainly welding are two types, fusion welding and solid state welding. Fusion welding. Fusion welding is accomplished by melting the two parts to be joined, in some cases adding filler metal to the joint. Example, arc welding, resistance welding, oxy-fuel gas welding. Solid state welding, heat or pressure are used to adhesive coalescence but no melting of base metals occurs and no filler metal is added. Example, friction welding, rolled welding and explosion welding. Now, arc welding. It is a fusion welding process in which the melting and the joining of metal is done by the heat energy generated by the arc between the work and electrode. An electric arc is generated when the electrode contacts the work and then quickly separated to maintain the gap. This temperature, actually a temperature of 5500 centigrade is generated by this arc. This temperature is sufficient to melt most of the metals. The molten metal consisting of base metal and filler. Electrodes. Two types of electrode are used, conjugable and non-conjugable. Conjugable electrode. This is the source of filler rod in arc welding. The electrode is consumed by the arc during the welding process and added to the weld joint as filler metal. The conjugable electrode will be changed periodically as it is consumed for each welding trails. Non-conjugable electrode. The electrodes are not consumed during arc welding, so this is the case. Some depletion occurs because of vaporization. Filler metal must be supplied by means of a separate wire that is fed into the weld pool. Gas welding. Gas welding are also the types of fusion welding. Now, diagram. Uh, Gas cylinder. Two separate two separate cylinder, oxygen and acetylene. Actually, gas cylinder, two separate cylinders, oxygen and acetylene. Black color for oxygen and maroon color for acetylene. Pressure regulator regulate the working pressure of the gases. Working pressure oxygen is between 0.7 and 2.8 and acetylene 0.07 to 1.03 kg per centimeter square. Work pressure depends upon the thickness of workpiece to be welded. Pressure gauge. 4 gauge provided, 2 on oxygen cylinder and 2 acetylene cylinder. Oxygen cylinder indicate the pressure inside the oxygen cylinder, which keeps lowering as the gas in huge up. Indicate the outgoing oxygen pressure through the hoses. Both oxygen and acetylene gas can be satisfactorily piped through the reinforced flexible rubber hose. Normally, the green hose is commonly used to carry oxygen and red hose is used to carry acetylene. Green hose means black hose. Welding torch. The welding torch has a mixing chamber in which oxygen and acetylene will be mixed and mixture is ignited at the torch tip. The pressure of oxygen and acetylene can be equal. To extinguish the flame, fuel gas should be turned off first, followed by the oxygen. Gas flow to the torch is controlled with the help of 2 needle valves in the handle of the torch. Welding tip. The welded tip is also called as nozzle. The oxyacetylene gas is ignited by a spark lighter or a flame lighter and it burns with a flame. Welding torch. There are 2 basic types of gas welding torch: positive pressure, also known as medium or equal pressure, and low pressure or injector type. The positive pressure type welding torch is the more common of the 2 types of acetylene and torches. Oxyacetylene. Metal to be welded are melted by using gas flame. The flame is produced at the tip of a welding torch. The common gas employed of gas welding is oxygen and acetylene. Flame only will melt the metal, so additional metal to the weld is supplied by the filler rod. A flux is used to remove impurities. The gases O2 and C2H2 can be stored at high pressure in separated steel cylinder. Flux. Actually, flux, the purpose of using flux, which is in a powder or liquid form, is to prevent oxidation and remove the impurities. The common flux used in the gas welding are made of sodium, potassium, lithium and borax. Gas tungsten arc welding. Gas tungsten arc welding are also known as TIG welding, tungsten inert welding, in an arc welding process that uses a non-conducible tungsten electrode to produce the weld. Working. The workpiece to be welded is placed on the work table. Electrode holder in which the non-conducible tungsten electrode is fixed. The non-conducible tungsten electrode and the workpiece are connected to the power supply. By supplying the electric power between the electrode and the workpiece, the insert gas from the cylinder passes through the nozzle of the cylinder passes through the nozzle of the welding head around the electrode. Insert gas surrounds the arc, protects the weld from effects, thus defect-free joints are made. Filler metal may or may not be used. Actually, by varying of types of flames, we have used to natural flame, carburizing flame, and oxidizing flame in gas welding. Neutral flames. Neutral flames by supplying equal quantity of oxygen and acetylene. Carburizing flame. It is also called as reducing flame, obtained by supplying more acetylene than the oxygen. And oxidizing flame. Oxidizing flame is obtained by supplying more oxygen than acetylene. Types of joint: butt joint, corner joint, lap joint, T-joint and edge joint. Butt joint are the axis are same passes through the line. Brazing. In brazing, a non-ferrous alloy is introduced in a liquid state between the piece of metal to be joined and allowed to solidify. In brazing, the filler metal has a melting temperature above 450 degrees centigrade but below the melting point of base metal to be joined. Joint produced by this welding is stronger than soldering. This process offers better corrosion resistance. Filler metal used in brazing include copper and copper alloy, silver alloy and aluminum alloy. In this process, heating is done by torch, furnace, induction resistance, bath dipping, infrared technique. Brazing method. These are the 6 types of brazing method. Torch brazing. In torch brazing, the source of heat for brazing is a gas flame torch. It may be oxyhydrogen or other gas flames. Dip brazing. In dip brazing, the pre-assembled metal joints are dipped in a bath of molten brazing metal. The molten brazing metal bath provides both the required heat and the brazing metal for the joint. It is usually adopted for a small part. Salt brazing. In salt brazing, the assembled parts are dipped in a bath of molten salt kept at a temperature slightly above the melting point of the brazing metal. Furnace brazing. In furnace brazing, the assembled metal joints with three-place brazing metals are kept in controlled atmosphere or vacuum furnace. Induction brazing. In induction brazing, high frequency induction current is used for heating the joints. Resistance brazing. In resistance brazing, the metal to be joined are held under pressure between the two electrodes. Soldering. Soldering is similar to brazing and can be defined as a joining process in which a filler metal with melting point not exceeding 450 degrees centigrade is melted, because soldering temperature is below 450 degree and brazing temperature is above 450 degrees centigrade, is melted and distributed by capillary action between the fairing surface of the metal parts being joined. As in brazing, no melting of the base metals occurs, but the filler metals wets and combines with the base metals to form a metallurgical bond. Filler metal called solder is added to the joint, which distributes itself between the closely fitting parts. Strength of the joint is weak and corrosion resistance is less. Difference between brazing and soldering. Brazing used for joining dissimilar metals, pipes, copper tubes, etc. Soldering to make electrical connection, to make printed circuit board and joining light sheet metal. Brazing the brazing temperature of the filler material is above 450 and soldering temperature below 450 degrees centigrade. Brazing filler metal are copper base alloy and silver base alloy, and soldering alloy of lead and tin. Brazing flux are borax, fluorides and chloride, and soldering zinc chloride. Brazing joint has a better strength and soldering strength is comparatively less. Thank you.